At a modern international airport, the arriving traffic activity must be carefully controlled, managed, and scheduled in order to facilitate an uninterrupted flow of service. Much like the managers of a modern airport, the wastewater treatment plant operator must manage incoming flow to the treatment plant. However, at the wastewater treatment facility, the operator has never enjoyed the luxury of complete control over the incoming arrivals. In ways that often baffle the treatment plant operator, you can expect to find almost anything arriving at the treatment plant with the raw wastewater. Items may range from rags to rocks, or sticks to bricks. These items interfere with the treatment process if not addressed by the treatment facility. That is why these solid trash-like objects must be removed and treated in the preliminary treatment stage. These solid materials can be broken down into two generic categories: screenings and grit. Screenings would include materials such as rags, small plastic items, and personal hygiene products. Screenings can include both organic and inorganic materials. Grit, on the other hand, is made up of sand and similar materials and is generally inorganic. In either case, screenings or grit will cause serious problems with downstream treatment units, resulting in such problems as clogged pumps, clogged pipes, jammed clarifier units, accelerated wear on process equipment, and interference with biological treatment processes. The removal and treatment of screenings and grit is essential for proper operation of the treatment plant, and also in meeting the standards of the facility NPDES permit. Removal of screenings and grit occurs at the treatment plant headworks in the preliminary treatment stage. Let's take a closer look at screenings. They are usually removed from the wastewater completely, or while in the wastewater, shredded into small pieces that generally do not interfere with downstream treatment units. Removal of the screenings is usually accomplished through the use of a bar screen or a trash rack, while shredding of screenings is accomplished with a comminutor, macerator, or similar device. Some treatment facilities may have both a bar screen and comminutor operating in series, while others may have one or the other. Now let's take a closer look at the equipment used in the screening process. A trash rack is used for removing large debris such as bottles, cans, bricks, and tree branches. A trash rack is usually a set of parallel bars placed at an angle or vertical in a channel. The bars are usually spaced 3 to 4 inches apart and may be either manually or mechanically cleaned. Regular removal of debris from a trash rack is necessary to prevent sewer line backups upstream of the unit. The debris removed from the rack needs to be disposed of properly in order to avoid problems with rodents and odors. The bar screen operates in a similar fashion to the trash rack. The main difference is the spacing of the bars. The spacing of the bars on a bar screen is generally 2 inches or less and may be either manually or mechanically cleaned. In either case, regular cleaning of the bar screen is necessary to prevent excessive head loss that results in wastewater backing up before the bar screen. If the wastewater backs up before the bar screen, the velocity of the wastewater will slow, allowing solids to settle out and could result in septic conditions, or it could cause the bypassing of raw, untreated wastewater into a stream. There are many types of mechanically cleaned bar screens. Some screens work with a continuous chain and rake mechanism that loop around and clean the bar screen. Some bar screens do not have any submerged bearings or chains and are cleaned with a long arm or a raking mechanism. Another type of mechanically cleaned bar screen is called the arc screen. The screen gets its name by the arc shape of the screen. Most mechanical screens are triggered by some type of automatic device that signals the unit when head loss through the screen increases. Automatic devices could include float switches, bubbler controls, and ultrasonic devices. And some mechanically cleaned screens are controlled by a timer. The debris removed from the bar screen needs to be dealt with in accordance with the appropriate solid waste regulations. Screenings should not be allowed to accumulate at the wastewater treatment facility, as they will cause problems. In addition to, or in place of a bar screen, a facility may have a comminutor. The comminutor is a device that is designed to shred the materials in the wastewater in order for them to pass through a 1/4-inch screen. The comminutor generally has a set of both rotating and stationary cutting heads. Some comminutors oscillate back and forth, while others turn in a complete circle. In either case, it is necessary to keep the comminutor equipped with sharp cutter heads to ensure proper operation. When cutter heads become dull, the comminutor tends to tear the material instead of shearing as it is designed to do. Generally, it is not effective to sharpen comminutor teeth, as sharpening only compounds the problem. Comminutor cutting heads and teeth take quite a pounding and need to be replaced periodically. In most cases, the majority of the wear on the comminutor occurs on the lower half of the unit. On some comminutors, it is possible to swap the bottom and the top teeth in order to even out the wear of the teeth. Failure to replace worn comminutor cutting heads could result in excessive strain on the comminutor gearbox, increased power usage, a buildup of rags and debris in the comminutor itself, and debris interfering with downstream treatment units. There are many types of comminutors and similar devices on the market today. One such device is known as the Muffin Monster. This device uses 2 rows of stacked cutter heads that travel at different speeds. These devices may be accompanied by a moving screen that directs rags and debris into the cutter heads. As with all mechanical equipment, extreme care should be used when working on or near this piece of equipment, as it is capable of chewing off body parts with ease. Warning: some older comminutors may have mercury seals. If you have a comminutor with a mercury seal, notify your local
DEP office
at once. Mercury is an extremely toxic element that requires special training and care in handling. Another important preliminary treatment process is that of grit removal. The simplest type of grit removal unit is the grit channel. In the grit channel, the velocity of the wastewater is slowed to approximately 1 foot per second. This is slow enough to allow the heavier grit to settle out while keeping the lighter organic material in the wastewater suspended. The velocity of the wastewater can be controlled by weirs or the shape of the channel. This type of grit channel may be cleaned either manually or by mechanical means, but most commonly this type of channel is cleaned manually. Another type of grit removal unit is the aerated grit chamber. The aerated grit chamber is usually a tank with a sloping bottom and a hopper at the lower end. The aeration lowers the specific gravity of the wastewater, allowing the grit to be deposited on the tank bottom by the rolling action of the wastewater, while keeping the lighter organic matter in suspension. The aeration also helps to freshen the wastewater and increase dissolved oxygen levels. The settled grit is usually removed with a chain and bucket type of mechanism. Due to the abrasive nature of grit, extra maintenance may be needed to keep the grit chamber in good working condition. Chains, sprockets, and bearings in this type of environment will wear much faster than similar types of mechanisms used on equipment such as clarifiers. Cyclone-type grit removal units may be used as well. These units take advantage of centrifugal force in removing the grit. A grit pump forces the grit-laden wastewater from the grit chamber hopper, where it goes through a cyclone-type separator. The grit is then removed while the wastewater passes on. In any event, the removal of grit is essential for the proper operation of the wastewater treatment plant. Grit will take up valuable space in biological treatment units and cause accelerated wear on pumps and other waste treatment equipment. Some other units that may be found in the preliminary treatment stage include pre-aeration chambers, flow equalization basins, and storm overflow basins. Pre-aeration chambers are used to freshen the wastewater and to remove oils and greases. Pre-aeration also helps with sedimentation, thus enhancing the downstream treatment units. Flow equalization basins help to even out the flow to the wastewater treatment facility. Most wastewater treatment plants have flows that fluctuate daily, weekly, or even seasonally. These basins help to better control the treatment process and prevent the washout of solids from the treatment facility. Flow equalization basins are aerated in order to keep the solids in suspension and the wastewater in an aerobic condition. A storm overflow lagoon operates in a similar fashion to an equalization basin. Overflow lagoons are usually designed for systems that have problems with inflow and infiltration. During storm flows, excessive wastewater is diverted to the storm overflow basin, where it is stored until the excess flow subsides. The wastewater from the storm overflow basin is then returned to the headworks of the plant for full treatment. Another benefit to the equalization basins, or the storm basins, is the ability to divert slug loads into them. If an accidental spill of a hazardous or a toxic substance occurs, the contaminated wastewater may be diverted to the basin for treatment or disposal, thus saving downstream biological treatment units from certain doom. In all cases, the equipment used for preliminary treatment of wastewater must be maintained in accordance with the manufacturer's recommendations. Regular inspections and preventative maintenance is a must for all wastewater treatment facilities. NPDES permits require all treatment plant equipment to be maintained well and in good working condition. Operators should use extreme care when inspecting or working on preliminary treatment units. Many of them may be located in or near confined spaces. Confined spaces present hazards that can cause death or serious injury to those who enter. Atmospheric hazards are the most common cause of death in confined spaces. No operator should enter a confined space without first-hand knowledge of confined space entry procedures. Proper equipment and properly trained personnel are mandatory in getting the job done safely. In some facilities, it may be necessary to pump the wastewater from the preliminary treatment units and onto the primary treatment stage. This is accomplished most commonly with centrifugal pumps or screw pumps. At this stage, the wastewater flow may be accurately measured. Accurate flow measurement is absolutely essential for proper operation of the treatment plant, proper reporting, such as DMR and Chapter 94 reports, and future design considerations. Calibration of flow measuring equipment must occur on a regular basis. Now that the wastewater has successfully passed through the preliminary treatment stage under the close watch of the treatment plant operator, the wastewater can now flow on to the next stage in the treatment process, the primary treatment stage.